Hello once again, welcome back to our tutorial on naming and writing formulas, whether the formula is an ionic or a covalent compound. When I say ionic bond, we are dealing with metal and non-metal ions, and sometimes we also refer to the polyatomic ions, which I have mentioned before that it is located in the lower portion of your periodic tables. So those are the polyatomic ions. When I say polyatomic, it has two or more elements found in the given compound. Here is the steps that we have to follow when we write and name ionic compounds with metals that form a single ion. Okay, step 1, first, you have to identify the cation and anion. So after you have identified which one is cation and which one is anion, then you have to name first the cation by its element name. So when I say element name, there will be no change in the name. So as is yung pangalan ng element. Third step, name the anion by changing the last part of its element, changing it to IDE. So for example, sodium chloride. Which one is a cation? Which one bears the positively charged? And which one bears the negatively charged? So for sodium chloride, the cations is sodium, which is a positive one, while the anion is the chlorine, which bears a negative charge. Now, following the steps, sabi dyan, name the cation first. So, which is the cation? Which is the sodium. So, that would mean the first name in the element is sodium plus the negatively charged, which is the anion, which is chlorine. But this time, you will change chlorine into chloride. So that is step 4. Write the name of the cation first and the name of anion second. So let's have an example. Okay, barium chloride, barium and chlorine. So which one is a cation? Which one is positively charged? Okay, if you are going to look at your periodic table, barium is a positive 2 ion, and chlorine is a negatively charged, a negative 1. So therefore, following the steps, name the cation first. So the cation there is barium. So what would be the next? Name the anion second, but this time you have to change chlorine into chloride. So that's why our chemical name is barium chloride. I hope you can follow. Okay, second example. Potassium and bromine. Okay, which one is a positively charged? Okay, very good. It is the potassium, which is K, positive 1. What about bromine? Okay, bromine is in group number 7, which bears a negative 1 charge. So it is an ion. So how do we name that? Using the steps. Okay, very good. So name first the cation, second the anion by changing into IDE. So the name of our compound is potassium bromide. Okay, last example. Calcium and fluorine. Calcium is in group number 2, which contains a positive charge of 2. Fluorine has a charge of -1. You might be asking why the formula is CaF2. Okay, remember when you have let's have an highlighter. Okay, calcium is a positive 2, while fluorine has a negative charge. Diba, in writing formula, dapat ito ay mapupunta dyan at ito ay mapupunta dyan. Okay? So, when you write the formula, it would be calcium. So, no need to write down 1. Kaya makikita mo dito that calcium do not have any number. That would indicate na there is 1 molecule. So, what about 2? Where can we find 2? So, 2 will be placed as subscript of fluorine. Okay, that's why in your chemical formula you have calcium and fluorine 2. So, what would be the name of our compound? So, the name of our compound is potassium bromide. So, once again, you have there the given is the calcium fluoride. So, first is we have to identify which one is a cation. So, what are the elements present? Calcium, which is a positively charged, a positive 2 charge, while fluorine is -2. You might be wondering why the formula is like that. Calcium F2. Okay, this is how we are going to write the formula given the charges. Okay, first, we copy the calcium and F2. So, why is it that F contains a subscript of 2? Saan po nanggagaling yung subscript ng 2? So, yung 2 ay nanggagaling po yan dito sa charge ng calcium. So, ilalagay mo siya as subscript. Now, what about fluorine? Okay, since fluorine has a negative charge of 1, dapat doon siya mapupunta sa calcium. But, since it is 1, there is no need for you to write down. Okay, since it is understood that there is a presence of 1. I hope you understand that. That is how we name. That's why it is very important that you know the charges so that when you write down the chemical formula, you know already what to write and where to place the subscript using the charges. Okay? Now, say for example, if the charge of fluorine is 2, for example, if you are going to place here 2, so magka-cancel out siya. Kasi nga, common factor is 2. So, 2 divided by 2 is 1. 2 divided by 2 is 1. So, kung titingnan mo yan, wala na dapat subscript. Pag 2 yung nasa sa charge ng fluorine. Okay, let's have one more example. How do we write a chemical formula? So that it would be very clear to you. So another example is aluminum 2 oxide, oxygen 3. So first in the step, identify the cation and the anion. So the cation is aluminum, which has a +3, while the anion is oxygen, which is -2. What would be the next step? So we'll copy aluminum and oxygen. But this time, why is it that aluminum has a subscript of 2 and oxygen has a subscript of 3? So 2 is taken from the charge of oxygen, which is 2. Question: are we going to write down the charge? There is no need for you to write down. Okay. What about oxygen? Why it is 3? So it is taken from the charge of aluminum. Okay, that's why your chemical formula is Al2O3. So you see how important is the subscript in writing down the chemical formula. Now, what would be the name of our compound? Based on the given steps, we have to write first the name of the cation and second anion by changing IDE. So therefore, our chemical formula will be aluminum oxide. I hope that's a little bit clear now. Because you might be wondering why the chemical formula is like that. Why there are subscripts. So this is the charges of some representative elements. You have their group 1, group 2, and group 3. Most likely they are known as cations. Okay, group 1, all of them has a charge of +1. Okay, group 2 has a charge of +2, while group 3 has a charge of +3. So since they are very far from the noble gas, they are more likely to share their electrons rather than receiving. So look at group 5, group 6, and group number 7. Group 5 has a negative charge of 3. Group 6 has -2 charge, while 7 has a -1 charge. Now, in this given set of elements, they are considered as anions. Why anions? Because they are more likely to receive electrons than to give. Say, for example, fluorine has 7 electrons in the outer shell, or yung valence niya. Mas practical ba na ibibigay niya yung 7 kaysa tumanggap na lang siya ng isa? So that they will follow the octet rule, which has an electrons of 8 in the outer shell. So just like the group 2, for example, magnesium has a charge of +2. So ilan ang kailangan niya to make it 8? So di ba 6? Mas tatanggap ba siya ng 6 or i-share na lang niya yung kanyang electrons to make it 8? So ganon sila. So you see, even the elements, they have the sense of sharing and giving and losing. Okay? So ganon din tayo. We share, we give, and sometimes we also need to lose something. Okay. Now, as the elements is very close to the noble gas, they are more likely to receive than to give. But when they are very far from the noble gas, they are more likely to share their electrons. Going back to the diagram, what about for the group 4? Group 4 is positive and negative charge. So, pwedeng magbigay siya or pwede siyang tumanggap. So, parang nasa neutral stage yung group 4. Either to receive or to give. Next one is, here is some common ions. You have lithium, sodium. So if you notice, we don't change the last the name of we don't change the name of the element. Why? Because they are all cations. Look at the second example. These are the non-metals. What do you notice in the name of the ions? Okay, we change the last letters into IDE. So instead of nitrogen, it becomes nitride. Phosphorus becomes phosphide. Oxygen becomes oxide. Sulfur, sulfide. Fluorine, fluoride. Chlorine, chloride. Bromine to bromide, and iodine to iodide. So remember that if the elements is cations, no need to change the name. What you will be changing is only the cations, the anions, I mean. Okay, which is mostly the non-metals. Let's try this example. Complete the names of the following ions. Okay, let's try number 1. Barium 2+, aluminum 3+, potassium positive ion. So for barium, are we going to change? Since it is a positively charged? Of course, we should not. So we remain the name, which is barium. What about for aluminum? Positive 3 charge. Still, it is aluminum. What about for potassium? Very good. It is also potassium. No need to change. Now, what about nitrogen 3 negative charge? Okay, very good. That's nitride. What about oxygen? It becomes oxide. Fluorine to fluoride. Phosphorus to phosphide. Sulfur to sulfide. And chlorine to fluoride. Okay, I know that's a little bit clear to you. How do we name ions? Bearing a cations and anions. Now, here are also some examples of ionic compounds with 2 elements. Okay, let's have this diagram. We have here the formula, the ions. First, you identify the cations, then the anions, and name of the given compound. Okay, let's have number 1. Sodium chlorine, sodium and chlorine. So the cation is sodium, which is positive charge. Chlorine is a negative charge. So the name is sodium chloride. Next example, K2S. K is a positive charge, or that is potassium. Sulfur has a charge of negative 2. So therefore, the name is potassium sulfide. So look at the formula. Why it is K2S? Because the charge of sulfur is 2, it will be placed a subscript for potassium. Next, magnesium oxide. Magnesium has a positive 2 charge, and oxygen has a charge of 2. So the name of the compound is magnesium oxide. Now you might be asking, why is it that the formula does not bear the charge? Remember, it has 2 charge. Pag dito kasi, hahanapin mo yung least common factor. Do they have common factor? Yes, they have 2. So 2 divided by 2 is 1. 2 divided by 2 is 1. Okay, that's why there is no need for you to write down the charge. Kasi mag-cancel out po sila. Okay. So, para mag-follow din tayo sa least common factor. Okay. So, mathematics will also be applicable here. Next example is calcium iodide. So, calcium has a positive charge of 2. while iodine has a negative charge of 1. So our formula is calcium oxide at calcium iodide. Why the iodine contains 2, it is taken from the charge of calcium, which is positive 2 charge. Okay, last example is aluminum oxide, as I have given us the example a while ago. Let's try. Write the name of the following compounds. Calcium and oxygen. Some of them are already examples stated just a while ago. So let's have number 1, that will be calcium oxide. And number 2, that will be potassium bromide. Then number 3, that will be aluminum oxide. 4 will be magnesium chloride. Now, let's try this activity. You have there bromine, negative charge. Sulfur has a negative 2 charge. Nitrogen has negative 3 charge. So what is written on the other side is sodium bears the positively charged and aluminum has a positively charged of 3. All you have to do is combine sodium plus bromine. What would be the formula given? It will be sodium bromide. So what will be the name? Sodium bromide. Okay, next, sodium and sulfur. What would be the chemical formula? It will be, sige, bromine pala muna. Bromine and aluminum. So you have aluminum and bromine 3. So saan nanggagaling yung 3? Nanggagaling sa charge ng aluminum. So therefore the name will be aluminum bromide. Okay, let's have number 2, column 2. Okay, sodium and sulfur. You have Na2S. 2 is taken from the subscript of the charge of sulfur. So the name will be sodium sulfide. Okay, next, aluminum 3 and sulfur 2. So the formula will be Al2S3. Al2, 2 is taken from the charge of sulfur, and 3 is taken from the charge of aluminum. Parang criss-cross lang sila. Okay? So what would be the name? So the name will be aluminum sulfide. Okay, last column. Okay, sodium plus nitrogen. You have Na3N. So 3 is taken or coming from the charge of nitrogen. So the name will be sodium nitride. Last, aluminum and nitrogen 3. So take note of the charges. They have the same charge, 3 and 3. So therefore, it will cancel out. So what would be the formula now? It will be aluminum AlN. So the name is aluminum nitride. Now what about for transition metals? Some transition metals contains 2 or more positive ions. Where can you find the transition metals? It is located in group 3B up to 2B. Okay. Yung mga nasa inner part dito. Yan, mula dyan. Okay. So these are the transition metals. So starting with group 6B, chromium has 2 charges, either positive 2 or positive 3. Manganese, positive 2 and positive 3. Iron, positive 2 and positive 3. Same with cobalt, nickel. Then you have copper 1 and copper 2. You have zinc, positive 2 charge. Okay, Ag is silver, has a positive charge of 1. Cd is cadmium, 2 positive charge. Au is gold, right? Gold 1 and gold 3. Hg is a mercury. Mercury has 2 charges, positive 2 and, well, they have positive 2. All positive 2. Wait, I'll check. Hg, no, it could be positive 1 and positive 2. Hg. That is element number 80. Positive 1 and positive 2. Then you have aluminum 3. Sn is tin. Tin 2 plus and tin 4. Pb is lead. Yes, right? It is lead. Lead 2 and lead 4. Now, for these examples, kung mapapansin nyo yung kanilang charges, special cases yung nasa transition metals. Why? Because the charges that they have, isusulat mo siya sa loob ng parenthesis at isusulat mo siya sa Roman numerals. Example, chromium 2. So, ganyan siya pag isusulat mo. Chromium 3, copper 1, copper 2, gold 1, gold 3, iron 2, iron 3. Then for lead, lead 2, lead 4, then tin 2, and tin 4. So nakalagay dyan, name the metals with 2 or more positive ions. The cations use are Roman numerals to identify the ionic charge. So, ito yung mga special case doon sa transition metals. Okay, let's have an example. What would be the steps? The first step, determine the charge of the cation and the anion. Okay, parang same with the steps in writing the charges of what we have in the ionic. Okay, still these are an example of ionic, but this time they have 2 or more charges. Okay. So name the cation by its element name and a Roman numeral in parentheses for the charge. Then third, name the anion by changing the last part of its element name to IDE. Parang ganun lang din yung process. Ang nadagdag lang dito ay isusulat mo yung kanyang charge into Roman numerals and place it inside the parentheses. Step 4, you have to write the name of the cation first and name the anion second. Okay, let's have an example. SB is 5. So, that will be antimony 5 sulfide. So, saan po nanggagaling yung 5 na charge? Ay, saan po nanggagaling yung subscript na 5? Nanggagaling po siya sa charge ng antimony. Okay, so ibig sabihin, antimony is the cation and sulfur is the anion. That's why the name of our compound is antimony 4 sulfide. Next example, you have silver oxide. So silver has a charge of 1. So oxygen has a charge of 2. So therefore, the name is mercury 1 oxide. Why 1? Because understood that the charge of mercury is 1. Next example, iron chloride. Iron 3 chloride. Why 3? Because the charge of iron here is positive 3. Okay, that's why when you give the name, it will be iron 3 chloride. So that is how we name compounds with variable charges, especially in transition metals. So what about, okay, this example, naming variable charges of metals. For you have iron 2 chloride, iron 3 chloride, then you have copper 1 sulfide, copper 2 chloride, tin 2 chloride, and lead 4 bromide. So, alam natin yung mga charges. So, pag nakikita mong ganyan, mapapansin mo naman yan pag ang first element mo ay kung transition metal siya. Now, let's have this activity. What do you think would be the correct name for Fe2S3? Okay, very good. So, you have iron 3 sulfide. Next, what about copper oxide? What would be the charge? So, you have a charge of positive 2 and negative 2. So, therefore, it is copper 2 oxide. This time, we'll be dealing with covalent compound. So when I say covalent compounds, covalent bonds, bonds of atoms held together by sharing electrons between non-metals. So pag sinabi natin covalent, non-metal plus non-metal. So walang involved na metal dito sa covalent bond. So for example, you have OH. Oxygen is non-metal, hydrogen is non-metal. So there will be sharing of electrons. Okay, since then the other one is there are shared electrons in the given example. So maybe this is chlorine, okay, since they shared 1 electrons. Okay. So this will be the comparison between ionic and covalent, because later on we'll be discussing in detail what covalent compound is all about. So the bonded name, usually pag ionic, salt yung bonded name. So for covalent, it would be a molecule. Bonding type, there will be transfer of electrons, while for covalent, there is sharing of electrons. So types of elements, metal plus metal and non-metal. While covalent, it is purely non-metals. So what about the physical state? Ionic, mostly in solid state. What about for covalent? It could be in solid, liquid, or gas. Melting point, high or above 300 degrees Celsius. While for covalent, below 300 degrees Celsius or lower. Then solubility, ionic compound dissolves in water, while covalent varies. Why varies? Some may be dissolved in water, and some might not be dissolved in water. What about for conductivity? Ionic is a good conductor of electricity, while covalent is poor conductor. So remember that ionic compounds transfer electrons in order to attain a noble gas electron configuration. But for covalent, there should be sharing of electrons to attain a noble gas electron configurations. So tatandaan po natin, ionic, there will be transfer, while covalent, there will be sharing. Okay. So regardless of what type of band, octet rule must follow, or they obey the octet rule, except for helium, since helium has only 2. So, in covalent compound, meron tayong tinatawag na single bond, double bond, and triple bond. So, what about for the single bond? Okay, single bond consists of 2 atoms held together by sharing 1 pair of electrons. So, pag 1 pair, so ibig sabihin, 2 electrons yun. For example, hydrogen gas. Hydrogen has one electron in the outer shell. So the other one also has 1 electron in the outer shell. So therefore, the bond is single bond. So isang bond lang yung mabubuo. That's for single bond. Okay, next. What about the electron dot structure? How do we know that there is only a single bond? For example, hydrochloric acid. Hydrogen has one electron, while chlorine has 7 electrons. So what they will be sharing is 1 electron of chlorine and the other electron of hydrogen. So therefore, the bond is single bond. Okay, next example. NH3. That's nitrate. Nitrogen has 7 electrons in the outer shell. 7 ba? No, it's 5. Electrons of nitrogen has 5 in the outer shell, or the valence electron of nitrogen is 5. Now, the unpaired electrons of nitrogen will be paired with hydrogen, but still, the bond is single bond. Kasi isang nabubuo dito sa HN, tatlong lines lang. Pero hindi sila naka straight line. So, parang single pa din yung bonding. Okay, next. Carbon and hydrogen. CH4. So, carbon has 4, right? 4 electrons in the outer shell. And there are 4 hydrogen that will be bonded together. So, therefore, it's still a single bond. Next. Carbon tetrachloride. So, carbon tetrachloride, carbon has 4 electrons, tama? And then, chlorine has 7. Then, you only have 4 pairings, sharing of electrons. So, that's why it's a single bond. Next is water. Oxygen has 6, while hydrogen has 1. So there will be sharing of electrons. 2 electrons of oxygen will be shared to the 2 electrons of hydrogen. Now what about for shared versus unshared electrons? When I say shared electrons, these are the pair of valence electrons that is being shared between atoms. When I say unshared, these are electrons or paired of valence electrons that are not shared between any atoms. For example, chlorine tetrachloride. How many shared electrons na meron lang? 4. 4. Tag-iisa galing doon sa chlorine. At doon sa carbon na 4. Ano yung mga unshared? Okay, unshared electrons are the electrons located in chlorine na hindi naka-pair doon sa carbon. Next example, NH3. Do we have unshared electrons? Yes, there is. The electrons located on the upper part of nitrogen, which has 2 electrons. And then the last example, hydrochloric acid. How many shared electrons? So, meron lang tayong 1 shared electron. So, 1 from chlorine and 1 from hydrogen. Are there unshared electrons? Yes, there is. There are 6 electrons that are located in chlorine. Those are unshared. Maybe you can practice this one. Practice Lewis dot structure. You have four chemical formula. You have F2, water, NH3, and then you have CH4. So you can identify the number of electrons, the single bond structure, writing down the number of remaining electrons. Those are the unshared electrons. Then the Lewis dot structure. You check if it follows the octet rule. Pag sinabi natin octet rule, pag binilang mo lahat, yung electrons na nandyan, kasama na yung shared, I equal to 8. Okay, except daw for hydrogen and helium. Kasi yung hydrogen, 1 lang talaga. So, pag meron kang dalawang hydrogen, hanggang dalawa lang sila. Okay? So, that's already octet rule. Now, what about for the double covalent bonds? Okay, sometimes atoms attain noble gas configuration by sharing 2 or more pairs of electrons. A double covalent bond is a bond that involves 2 shared electrons, a total of 4 electrons. For example, oxygen gas. How many shared electrons? There will be 2. So, a total of 4 electrons. So, when there are 4 electrons, it would create a double bond. What about carbon dioxide? It is also a double bond. Okay, oxygen has 6, carbon has 4, and the other oxygen is 6. So how many shared electrons? 2 coming from the first oxygen and 2 from carbon. And another one is 2 electrons from carbon and 2 electrons of oxygen. So it makes up a double bond. Now what about the triple covalent bond? How do we identify whether they have 3 triple bond? Okay, this is a bond that involves 3 shared pairs of electrons, a total of 6 electrons. For example, you have there nitrogen. Nitrogen has 5 electrons in the outer shell. So, how many bonds that it will form? There will be 1, 2, and 3. The 3 unpaired electrons will be paired with the electrons of the other nitrogen. So, this is a nitrogen gas. So, ganyan yung kanya. If you write down in symbol, that will be nitrogen gas. So, that is a triple bond. You might be asking, does it follow the octet rule? Sige, bilangin natin. Okay, the first line has 2, second line has 2, third line has 2. So, that's 6. Plus 2 on the opposite side, you have 6. Pag binilang mo din sa kabila, opposite side, meron ka ding dalawa, so that makes it 8. So, it follows the octet rule. Okay. Right. So, to sum up with covalent bond, there will be 3 examples. The single bond, double bond, and the triple bond. So, ganyan lang yung category of covalent bond. But of course, when we talk about polarity, meron din siya, non-polar and polar. By looking at the electronegativity of electronegativity of the given elements or molecules. Maybe you can practice this one. You have oxygen gas, carbon dioxide, nitrogen, and HCN. So, number of valence electron, the bond, then the remaining electrons, the Lewis dot structure, then you check whether it has 8 electrons or it follows the octet rule. So, classification of bonds, as I have mentioned, whether they follow non-polar, polar, or ionic. So, based on the electronegativity difference. Pag non-polar siya, from 0 to 0.4. Polar covalent, from 0.5 to 1.9. Pag ionic, 2.0 to 4.0 and above. So, yun yung ating classification. Aside from, it has a double bond, single bond, or triple bond. That is only true for covalent. For ionic, ano siya, kaya usually pag ionic siya, single bond. Okay. This is a very useful flowchart, especially in naming compounds. So the first question that will come up to your mind when you examine what type of bond it is, or what type of compound is the given, first, you will ask yourself, is there metal in the compound? How do you know that there is metal? You will be needing your periodic table. Okay? But most likely, yung mga non-metals naman ay nasa group 3, group 4, group 5, group 6, and group 7. Pag kabisado mo sila. Pero pag hindi, kailangan mo ng tulong ng iyong periodic table. Okay, next will be, if your answer is yes, ang sunod na tanong is the metal a transition metal? If your answer is yes, ang sunod na tanong, count the different elements. Ilang elements meron dyan? Pag dalawang element lang, 2 elements, transition metal and non-metal, it is ionic binary. What would be the step? Okay, determine first the charges of the transition metal and write the charge into Roman numerals after the name. Halimbawa, iron 2 or iron 3. Then, the step will be name first the metal, then second, the non-metal by changing the last letters into IDE. Halimbawa, iron 2 chloride. So, iron 2. So, that is Fe2Cl. Now, going back to the question. Are there 3 or more elements, transition metal and polyatomic ions? So, pag meron kang polyions, yung mga ions na nandyan sa lower ng inyong periodic table, ang tawag sa kanya ay ionic ternary. So, pag ionic ternary siya, name the transition metal first. Okay, determine again the charge. And then write it in Roman numeral inside the parenthesis. Then, Copy the name of the polyatomic ion. Remember, never change or do not change the name of the polyatomic ion. So, as is na yon. So, kung makikita mo yun sa periodic table mo, sa baba, yung mga polyatomic ion natin, may mga pangalan na yan. So, kukopyahin mo lang siya. Hindi na kailangang papalitan ng IDE. Remember that. Again, I'll repeat, hindi po kailangan palitan ng IDE yung polyatomic ion. As is po yun. So, kung anong nakalasulat doon, kukopyahin mo lang. So, yun lang yung idadagdag mo doon. Sige, going back to the question. What about if our answer is, there is no transition metal? Yung sagot natin ay no. So, what would be the next question? Count the different elements. If there are two elements, if it is metal and non-metal, it is ionic binary. Follow the rule. Name first the metal, then second the non-metal. This time you will change the non-metal into IDE. Now, what about if there are two or more elements? Metal and polyatomic ions. So, therefore, it is ionic ternary. Are we gonna change into IDE? No. Name first the metal first, then second the polyatomic ions. Nakalagay dyan, do not change. Do not change the words ending to IDE. So, as is siya, katulad din dito sa transition metals. Now, going back to the first question on the upper part, what about if our answer is no? What will happen next? Okay, ang tatanong mo agad is the first element hydrogen. If your answer is yes, next question, it will be acid form. So, pag acid form siya, pag meron siyang hydrogen, usually, hydro siya. Hydro ang root word. So, it will end up with IC or it. That is for acid. Halimbawa, hydrochloric. Hydrochloric acid. Now, what about pag polyatomic ions? So, pag polyatomic ion siya, either nag-end siya ng ATE or plus IC or, yes, IC, acid. Pag poly ions ending in ITE, then the root ions is OUS. Ano bang may example dito? Okay, for the polyatomic ions, halimbawa sa taas, copper sulfate. Okay? Pag dito sa baba, OUS, sige mamaya, we'll have examples of how do we name polyatomic ions ending in OUS. Usually, mga bromos yun, mga ganon. Okay? So, what about if there is no hydrogen present? Ang sunod na tanong mo ay, count the different elements. So, pag isa lang, that will be diatomic molecule. Halimbawa, we have only 7 diatomic molecules. Remember that? 7 lang sila. Bromine 2, iodine 2, nitrogen 2, chlorine 2, hydrogen 2, oxygen 2, and fluorine 2. If there are 2 elements present, then it is covalent binary. So, pag covalent binary siya, kaya usually, gumagamit tayo ng mga prefixes. Halimbawa, mono, di, tri, and tetra, penta, hexa, and nona, hanggang 10. And change the last element into IDE. Okay, we'll have example on this on the next slide. Okay, here is an example of determining the charges of transition metals. The given example is iron 2 and oxygen 3. So may mga nakalagay dyan. So when you balance the equation, the name of this compound will be iron 3 oxide. Now there will be prefixes here. The covalent, this is only for covalent compounds. You'll be using prefixes from mono up to deca. Then you have there the list of polyatomic ions and the Roman numerals that you will be using exclusively for transition metals. We have here some examples that we'll be using. Ionic compounds, example, metal and non-metal. So you have chlorine and potassium. So name first the metal and second the non-metal, changing to IDE. So you have potassium chloride. Okay, number 2, that will be aluminum oxide. Okay, third, you have metal and polyatomic ions. So name first the metal, which is magnesium, and the polyatomic ion. Hanapin mo lang dito sa list. So that will be magnesium nitrate. And then, the second example is sodium acetate. Transition metals and non-metal. You have iron and oxygen. So this will be iron 3 oxide, copper 2 chloride. Okay. For transition metals and polyatomic ions, name first the metal, which is copper, then chromate. Okay, what about for zinc? So you have zinc hydroxide. So mapapansin mo walang nakalagay na 2 kasi magka-cancel out yan when you balance the equation. What about for covalent compound? You have P2O5. So this time hindi siya nag-criss-cross kasi hindi naman sila, ang mag-criss-cross lang, ang magpapalit lang ng charges ay cation and anion. Pero sa non-metal and non-metal, as is siya. So hindi siya magbabago. So di ba pag nalagay dyan 2, it will be diphosphorus pag 5 pentaoxide. Okay? So ang papalitan mo lang yung last na element with IDE. Okay, second example, carbon and chlorine. So it will be carbon tetrachloride. Pwede bang lagyan ng monocarbon? Yes, pwede. So it could be monocarbon tetrachloride. But basically, hindi na ginagamit yung mono. So carbon tetrachloride. What about metal and polyatomic ions? Halimbawa, itong chlorine 2. Paano ba siya isusulat? Paano siya papangalanan? Kasi covalent compound. Okay, it will be chlorine. Then you have bromine. Okay. So example for acids. You have hydrogen plus the element. So this will be hydrochloric acid. So number 2, H3P. This will be phosphine. Hydrogen plus polyatomic ions. So this will be sulfuric acid. Then you have sulfurous. Ito na yung example kanina. Sulfurous acid. Yung mag-end up ng OUS. So paano? Pag ang di ba mag-end up sa IC pag greater yung number ng oxygen. Hydrogen, oxygen, yes. Oxygen. So you have SO4. Yung isa naman, SO2. So pag mas lesser, OUS. And then the last example is phosphoric acid. Okay? So these are examples of naming ionic and covalent compound. Okay, let's try this example. Name the following covalent compounds. All of the given examples are covalent compound. Now you have here the prefixes that you will be using, mono up to deca. Okay, let's have the first example, letter A. So that will be silicon tetrafluoride. N2, that's di. So dinitrogen trisulfide. Letter C, hydrogen bromide. D, that is bromine. The second example is, the given is the chemical name. This time, you'll be writing down the formula. So pag diboron, ibig sabihin, there will be two molecules of boron. What about hexahydride? Hexa means 6. So therefore, the formula will be B2H6 diboron hexahydride. What about letter B? Nitrogen tribromide. So may subscript po ba ang nitrogen? Wala. So what about the bromine? There will be a subscript of 3. So therefore, the chemical formula will be NB3. Last is letter C, sulfur hexachloride. Sulfur do not have any subscript, while chlorine has 6. So SCl6. Then letter D, diphosphorus pentaoxide. So diphosphorus P2O5. So that is how are we going to write the chemical name and the formula, or vice versa. I hope you learned something from writing and naming covalent and ionic compounds. So that ends up our short tutorial on naming and writing chemical formula involving ionic and covalent compounds. So I hope you will learn something from this tutorial, and thank you for watching. I hope this will help you in our coming lessons. Okay, thank you and keep safe. Once again, this is Mrs. Teresita B. Moreno. Thank you guys.